Hi, welcome to video 4.4a, Introduction to First Fundamental Theorem of Calculus. This is extremely simple. Okay, so out of the book, if we look out of the book right now, First Fundamental Theorem of Calculus tells you if a function f is continuous on the closed interval from a to b, and capital F is the antiderivative of little f. So the integral of little f is big F of x. And on the interval from a to b, then the integral from a to b of little f of x dx equals whatever you get as an integral, and then you evaluated at the top number minus you evaluated at the bottom number. The proof is ridiculous. We're not going to get into that, but just to give you a quick example here, if you integrate x squared minus 3, you get x cubed over 3 minus 3x. You're going to evaluate that. I prefer to have a straight line here from 1 to 2. You always plug in the top number first. 2 cubed over 3 is 8/3, minus 3 times 2 is 6, and then minus, and then you plug in the bottom number. So basically it's just going a little bit further than we were going before. We're just actually evaluating it. So you're going to get a number as an answer. Make sure you do top minus bottom, not plus. Just to let you know, on your calculator, you can actually do integrals on your calculator. And let me pause for a second to pull up the calculator. Okay, so we're going to look at the calculator right now. In our nice little template, we have both the indefinite integral and the definite integral. The definite integral is what we're just talking about now, where there's going to be a number at the top and bottom. So for example, if you did the integral of, say, x squared, and it'll automatically say d what, dx, you're going to get, of course, I'm not in the right mode. Doc 7.2, for some reason I'm in approximate mode. Let me put myself back into, okay, so let me redo that and you'll get x cubed over 3. The one thing it does not do is it does not give you the plus c. If I want to do a definite integral with the calculator, then you'll have the definite integral from, let's say, 3 to 7 of, I don't know, x cubed dx. Now, you and I know that if we actually integrated x cubed dx, we get x to the 4th over 4. If we then replaced x by 7 and then minus and then replaced x by 3 in that answer, we would get 580. So you will get a numerical answer. Okay, so I just did this exactly. This is from 1 to 7, you would get 114. Now, of course, by hand, if you did this example from 1 to 7 of x squared, you'd integrate to x cubed over 3. Notice we don't put the plus c anymore. We don't need it because the c's would end up canceling. And then from 1 to 7, plug in the top, minus, plug in the bottom, and you would get that answer. Don't worry about the area thing right now. We'll come back to that later. Okay, so here's number 8, integral from 2 to 5 of negative 3v plus 4 dv. So first we're going to integrate. We get negative 3v squared over 2 plus 4v. We're integrating that from 2 to 5, so this means evaluated from 2 to 5. You're going to plug in the top number, which is 5 first, so you're going to get negative 3/2 times 5 squared plus 4 times 5, and then minus, and then you're going to plug in the 2. Now be careful, you will need these parentheses because you will be subtracting, you'll be distributing that negative. Okay? And again, if you wanted to, you could do it on the calculator. You could do second 7, you could approach it that way. I think it's just easier to use the template. I'm not even going to say that. Okay. All right, so just use the template to do that, and you'll get the actual answer if you do that. Okay, here's another one. So you have the square root of 2 over x. So the first thing I would do is break that up into root 2 over root x, and then rewrite that as root 2 times x to the negative 1/2. So once you do that, then you can pull that root 2 on the outside. The over root x becomes x to the negative 1/2 on top. We're now going to integrate the x to the negative 1/2. We'll get x to the 1/2 over 1/2, which is times 2, and that's going to be from 1 to 8. Now here's a nifty little trick. You can roll that 2 outside here and just evaluate root x from 1 to 8 rather than 2 root x from 1 to 8. Again, plug in the top number first, then the bottom number. Simplify. In this case, I multiplied through, and you get an answer of 8 minus 2 root 2. And over here, remember there's no product rule. Remember also you cannot take the integral of the first factor times the integral of the second factor. That does not work. So you actually have to multiply through. Square root of t is t to the half. You multiply through, you get 2t to the half minus t to the 3 halves. You integrate, you get 2 times t to the 3 halves over 3 halves, which is times 2/3. Over here, you integrate, you get t to the 5 halves over 5 halves, which is times 2/5. And we're evaluating that from 0 to 2. So we plug in the 2 first. Actually, I'm rewriting this a little bit. I'm rewriting that as 4/3 square root of t cubed minus 2/5 square root of t to the 5th. And now I'm going to plug in the 2 and here, and then minus, and then in parentheses, I'm going to replace them both by the lower limit of integration, which is 0, and blah, 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 blah. You'll get 16 root 2 over 15. Here's number 22. Did that on the next page too. Never mind. So again, there's no quotient rule, so we have to split it up. So we're going to pull the 1/2 on the outside, and then we're going to split x over x to the 1/3 minus x squared over x to the 1/3. Simplify those. Integrate. That'll be x to the 5/3 over 5/3 minus x to the 8/3 over 8/3. And now we're replacing, again, we're evaluating it from -8 to -1. So it's always the top number, whether it's bigger or smaller, makes no difference, minus, and then the bottom number. And that's a lot of calculations over here, blah, 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 and it gives a certain number. And that's the end of video 4.4a.